The topic today is we're going to cover about regression. So this is an extra videos in order to help you to prepare for your final exam projects. Now, there are 4 topics we're going to cover today, but probably we're going to cover 3. First is simple linear regressions. Then, secondly, we're going to cover 4 multiple linear regressions. Third, we're going to cover for multiple linear regression with the extension to dummy variables. And in the fourth, we're going to cover for the polynomial regressions, which is the one I will show you in class. Okay, so for the 3 example here, we're not using the same example below here. So I'm going to spend a little time describing about this example. Now, in this example, this is about we're doing the research on about the accountant jobs incomes. That means that I'm interested to know. To know which factor affect to. Okay, it's better to use the word as the relations to the salary. Okay, and the important here has the relation to is the preferred word, but I'm going to tell you later why we have to use this word later. Okay, now let's begin with about the simple linear regression, in which we only have one variable of y, which is dependent variable, and one variable x in which is the year experience. Now, in order to construct this, we're going to go to data analysis, regression, and for y, I'm going to select from salary. For x, I'm going to select year experience. And I'm going to check for a label because it's to let you know that the first row is the label, output range. Now for the output range, I'm going to choose here and press OK. Now this is the value they obtained, so here's the value need to be formatted a little bit before. And I strongly suggest you to format all the number. Okay, here's the value that we got. Now, several questions that we need to answer. First, okay, what is our equations? So here our equation in the form y is equal a plus bx. So in which here we can see that the equation is from that y is going to be 6.369 plus for 1.431 multiplied by x. Okay, this is our equation. Then secondly, we're going to ask ourselves that if this is a good equations or not. Okay, so in order to answer this question, there are 3 parts as I mentioned in class. First, 2a. Now where is 2a? That is that for the f test, okay, which I call the general test. So here we can take a look at since our f test p-value is 0, okay, we have here p-value is less than alpha, okay, because alpha normally from 1%, 5%, 10%, so here 0, 0, 0 is going to be probably less than alpha. So therefore we're going to reject the hypothesis, okay, which means that we're going to make the conclusion that y has the relation to at least 1x. So normally, because in this we have the simple linear regression in which only one y and one is x, so it's not okay. To be here we have t-test, okay, in which t-test here is gonna be, I call it detailed test, in which we're gonna testing for about the coefficients of b here. That is 1.431. Normally, because in the simple linear regression there is a very strong relationship between the t-test and the f-test is, but I don't want to mention, to make you confused. So just follow all the full step. Now for the t-test here, I'm going to check it. So the intercept here is 1.4, and then it has the p-value here is 0, which means that, okay, t-test here I have my p-value, which is also less than alpha, and then I want to reject the hypothesis, which means that beta is different to 0. Okay, so what does it mean? This means that sorry, this means that, okay, the year of experience does have that has the relation to the salary, okay, and this relation is positive. Okay, so this is the first one for us about. So I'm gonna answer this. I'm gonna write down check one. Okay, simple linear regression. Okay, but we're already done for this. I'm gonna highlight this a bit. Now, secondly, probably we don't need this. You're gonna need to use that, but in your level, I'm gonna skip this. Okay, and save some space. Significant, I'm going to change to P. Okay, significant P. Let me change to P value. Okay, this is much better. Now the second thing is that, okay, we're done. Then we're going to the second things here, which is the multiple linear regressions. Now in this multiple linear regression, I'm going to extend into. I'm still keep my dependent variable, but for my independent variable, I'm going to extend into year of experience and gender. Okay, so we take a look here, in which our gender has 0 stand for male and 1 for female. So for example, the first person here, I know that this is a man, okay, and the second person, I know that this is a woman. Okay, so very simple like this, and we don't care about the education yet. Now for second, what I care about, multiple linear regressions. Now, multiple linear regressions, in order to do that, first I want to cut this, okay, in order to save some space for us. I'm going to put it here, okay, because we want to finish that. I'm going to move this here, okay. Multiple linear regression. Now, in the multiple linear regression here, simple extensions, and the point is that first I'm talking about dummy variable, okay, dummy variables here, because dummy variable here we have two genders, two characteristics, two gender, two characteristics. So which means that we only need 2 minus 1 is equal to 1 dummy variables. Dummy variable. Okay, so we gender here, so there's no problem to it. Now let's go for that. So I'm going to select data analysis, regressions, and then I'm going to select, well, for Y still keep the same as salary, but for X now I want to extend into year of experience and gender. Now my result here, and then press OK. Now a few formatting before we go. Okay, good. Then this. Okay, now for significant F, I'm going to change to P value. Okay, coefficients, standard deviations, things. Now we're still doing the same. Stick to the same here. What is our equations? Okay, our equation has the following form, that Y is going to be equal to beta 0 plus beta 1 multiplied by x1 plus beta 2 multiplied by x2. Okay, so in which Y is going to be equal to 7.868 plus 1.427 multiplied by x1, which is our year of experience, plus for no, it's actually minus for 2.819 multiplied by x2. Okay, now we come to second. Is this a good equation? Sorry, I forgot something. Now I'm going to back to my symbol like that. We still have the third one, I forgot, which is 2c's, that we're going to test r square. Okay, sorry, r square. I will enter this. R square is going to be equal to here. Okay, so this means that this is kind of a fair model, okay, because this model can explain only allow 61% of the data, and the rest 30% is come from the error. Okay, so now we're going to discuss that more. Now we're going to back to this. Sorry, this 2A still F test for the general test. Yeah, it is so far we still have our p value. It's still less than alpha, of the alpha level. So we're going to reject the hypothesis, which means that y is explained by at least 1x. Okay, then we continue for 2b. On the 2b, you're going to have the t-test, which is called detail test. So for the detail test, here we're going to have the p-value, which is still less than alpha. Well, we're going to check it now. Let's see, all these things, they are less than, well, 1%. So I can write that O p-value less than alpha. Okay, so I still reject the hypothesis, in which means is that although beta I, okay, I mean beta I means beta 0, beta 1 or beta 2, I mean beta I is going to be different to 0. Especially I'm only concerned about beta 1 and beta 2. Okay, beta 0 is about intercept, not concerned here. Now for beta I is going to be different to 0. That means that I'm going to say that, which means, well, x1 and x2 have the relation to, okay, has the relation to y. Okay, 2c, okay, in 2c, and we're going to talking about yes, about R-square. Okay, for the R-square here, in which is going to be 0.67. So here it means that 67% is explained by model is data. Okay, and the rest 33% is GM. Okay, very simple. Now here, because we have two models already, so I like to make some comparison. Okay, so there are two things. Okay, now I should write down here. And write what conclusions can we make? Okay, first, now this is we make the comparison between model 1 and model 2. Okay, so in order to say that, because first that we can see that all the model they have about the coefficient is significant, which is has the relation to y. Okay, here we have about year experience have the relation to y, and here we also have year experience and even gender have the relation into the salary. Now if everything is okay, then we're going to compare into the R-square, in which we're going to have about model 1 and model 2. The R-square in the model 2 is on about 67%. Meanwhile, the model in model 1 is only about is only about 61%. So therefore, here we can see that model 1 is better than model 2. Model 2 is better than model 1. Sorry, I reverse. Now the second thing is extremely important, and I believe that many people make the mistake here. Now here's the thing, which also explains why you cannot, okay, I have to bold it in here, why you cannot say that say that x to is the effect to y. Okay, now the clearest example here is that, but you cannot tell it right now. Okay, if you say that x effect to y, okay, now let's see what's going on here. If you say x effect to y, then you're going to notice that in x2 here, okay, x2 here, which is gender, and the p-value is very significant, which mean that, okay, what does it mean? Which mean that which one is then stand for, okay, we need to write out again, 1 is stand for female, 0 stand for male. That means on this equation, and you have see a minus here, which means that if it is that is a female, then the salary is going to be reduced by 2.8 million. Okay, and therefore that if you say that x affect to y, okay, in specific, very specific, which means that x2 affect to y, which mean that there is is gender inequality. Okay, here in about accounting jobs. This is, remember this, okay? Remember this, okay? Right now, I do not, okay, I have to note it. I do not answer yet why we cannot say like that, okay? But here, we only say that, okay? I'm only give you the example in case what happened if you say like that, okay? And given this, you're gonna see this in the model 3, okay? So right now, let me take copy. Actually, we don't need this one, so I'm gonna skip this, cut a little bit, okay? And here we go. Done. Now, okay, done. Very beautiful. Now we're coming to the third one, okay? Let me erase this a little bit. Now we're coming to the third one, which is about multiple linear regression with extension to make dummy variable. Okay, so here we extend to dependent variables, we extend to year of experience, gender, and education. In the education here, you can see that we have one which stands for person with the high school graduation certificate or lower. Number 2 mean people with bachelor degrees, okay, that's mean official bachelor in economics, in accounting, things like that. And number 3 is people with about the degree in master or higher, okay. So the first thing here is that, okay, for gender, we only have 2 characteristics, therefore we only need 1x, okay, which is here is x2, okay. Year of experience only x1, and the problem here is the education. We have 3 characteristics, so therefore that we only need 3 characteristics, so therefore we need 2 dummy variable, okay, which is, let's write down 3 minus 1 is equal to dummy variable. Okay, but the problem is that the data is organized like 1, 2, 3, and if you have to remember that dummy variable can only take place between 2 values, 0 and 1. Okay, so therefore that this is not appropriate. So therefore that here in this one, let me write down a little bit. 3 multiple linear regression. Okay, multiple linear regression with the extension to dummy variables. Okay, okay. Now in this one, the first thing we have to do is that we have to refiltering the data. Okay, I'm gonna cut this a little bit. Cut this here, refiltering the data. How I'm gonna refill the data? Now I'm gonna copy everything like this here, nothing. Then next is about gender. Okay, no problems here. And then for dumb of education, now I'm gonna have the first edu for dummy 1. Okay, edu dummy 2. Okay, 2 variable for dummy for the characteristic of educations. Now the other, okay, I just copy this, equal to this, okay, and just scroll it down. Salary, well, my salary is going to have to be equal to this, no problem. Year experience is going to be equal to this, no problem. Gender is going to be equal to gender, no problem. Now for education, I'm going to use the if function here, in which if, okay, if education is equal to, okay, in which here I say that edu for dummy 1, okay, I'm going to note, make a careful note, okay, edu dum is equal 1, which means bachelor degree, okay, and edu dum 1, I have edu dum 2 is equal 1, which means master blah blah. Okay, so here's that if the education here is equal to 1, okay, sorry, is equal to, okay, because 2 is bachelor degree here, and the value on this side will be equal 1. Otherwise, then it's going to be 0. Okay, if it is bachelor degree, then it's 1. If not, then 0. Okay, equal next if, okay, if this one is equal to 3, then this one will be 1. Otherwise, it will be 0. Okay, that's mean that if this person is having the master degree higher, then the value here is going to be 1. If not, the value here is going to be 0. Okay, it's going to be 1. Now I won't have to scroll down everything. Okay, beautiful. Okay, then I have the data for this. Okay, I have the data now to do for this. Now what the hell do I do? Then I'm going to run for the regressions here. I just go to data analysis, regressions. I have my year of experience, which is salary here. Okay, no problem. Then I have my input range X here, Y here, and I'm going to collect the entire data here. Label still yet here, I'm going to move a little bit further, and I press OK. Okay, then I have everything. Send arrow. Now, okay, make a little bit format. Well, actually, you have to learn about. In our work, I expect you to do a proper format. It's very important. Okay, it's not only make it easy to read the number, because you can see that those two, okay, the one here is very easy to read compared to this one. Okay, I have no idea what it has it. Okay, now here I want to change this into p value. Okay, we still stick to our plan. Well, what is it? So we're going to spend some space. Now, first, what is our equation? Okay, our equation is here going to be y is going to be beta 0 plus beta 1 multiplied x1 plus beta 2 multiplied by x2 plus beta 3. Okay, beta 3, which is a2 here. Okay, a2 dummy variable 1 multiplied x3 plus beta 4 multiplied by x4. Okay, that's done. We're done. So y is going to be equal to 3.12 plus 1.462 multiplied by x1, okay, which is year of experience, which is x1, plus then gonna be next is well gender. Okay, for my gender is gonna be like how much? 0.006 multiplied by x2 plus 3.706 multiplied by x3 plus 7.879 multiplied by x4. Boom, bravo. This is my equations. Then I'm still to stick for next is that this is a good equation. So not okay. This is a good one, not page check. Okay. What do I have here? I will still stick to the plan. F test for the general test, as I call it the name is. I have the p-value is which is less than alpha for all of that. We'll see. Oh my god. Somehow I just messed up thing. Okay, don't worry, I'm gonna find out the p-value for you. P-value is gonna be extend this a little bit from my only. Sorry, I'm gonna be f inverse from okay probability distributions. Okay, f distribution. This one degree of freedom is going to be this. Degree of freedom is going to be this. Cumulated through f and definitely when I want this. Okay. Okay. Sorry for delete that. Now when I have p value is less than alpha, well yes, then I want to recheck the hypothesis, okay, which means that there is at least one x have the relation to y, okay, or y is explained by at least one of the x. Now, 2a already, and I'm going to 2b. Okay, for 2b is going to be t-test or t-test. Okay, for the detailed test here, you're going to take a look and you're going to see something. Now for the detail test here, I'm gonna do direct on this. Here you're gonna see this. No, reject. Okay, reject. This is not reject, reject, and reject. Okay, so here in this, well, here the gender is reject, which is very different to this one, in which our gender is not rejected. Oh, new things. Okay, so here we're gonna have only about variable of okay, year of experience Now we start to analyze these equations. Like in this one, we have this one, the base salary is kind 3,100,000. Then is equal to proportional to about the year of experience, which 1.46, okay, multiplied by the year of experience. Then x2, because we don't have any relation between x2 and y, so therefore that nothing happening here. That's you're gonna see here. Okay. Third is about this one. Okay, that's mean x3. That's mean that if a person having now, if a person is high school degree or lower, I mean x3 will be 0 and x4 will be 0. That means your equation only having this one only. Okay, no the rest. But if the person having the bachelor degree, that means his salary gonna be increased by x3 gonna be 1, x4 gonna be 0, so the salary gonna be increased by 3.7. Okay, and so the same if the person having the master degree or higher, which means here you're gonna see you won't have this because this one x3 is equal 0 and x4 is equal 1, so that means the base salary increased by 7.8, somewhat like that. Okay, good. And now we're going to come to the comparison and conclusion. Okay, comparison. No, sorry, I have more to see. However, swear. Okay, my swear here is about wow. That means that 80% of the data is explained. Okay, while the rest 18% is error. Wow, perfect. Now, we're gonna make some comparison here. Okay, for the comparison. Now, the first things in about the comparison is that I want to explain bandwidth elsewhere. Okay, bandwidth elsewhere to see how good a model it is. Okay, so as you can see here, I have model 1, model 2, model 3. Then for model 1, you're gonna have the p-value is gonna be then for model 2, you're gonna have value is gonna be going here, and your model 3, the model is gonna be here. Okay, so as you can see, first model 1 explain the poorest. Okay, poorest compared to the other two. Then in the middle is model 2, and the last one is model 3. Okay, and now secondly, take a look at this. Okay, boom. Why can we say that x affect, well actually I forgot affect, which one is the verb, affect to y. Okay, now you can see that if you say that x affect to y, then on the second model you can say that the gender affect to y, which means that, okay, which means that there is about gender inequality. But in this one, let's take a look. You still include about gender here, but this gender is not significant, so therefore insignificant is not mean that you have no evidence to reject that this coefficient is different to 0, which means that gender doesn't have any effect to the salary. Okay, and then here only about dummy variables. Okay, dummy variable here, edu dum 1, edu dum 2, they are having the effect to y, which means that the higher education the person have, the higher salary that person have. Now, how is it going to be possible? Because now let's take a little about this contingency table in which, let us say, male, female, okay, education 1, education 2, and education 3. Now to do this, I want to make a little bit analysis. Now home, sort, computer, and not this one, small storages. Okay, change things. When I'm changing things, now here, let's see what how do I have. Yes, and then education. How many? Yeah, it's okay. Now I'm going to use the function count if, okay, range. So male is only from 0 to 0. So I'm going to select this one. Okay, this is the range that I count. Max. I want to. Okay, I press F1 to keep this row to be stable. Okay, this column, we're gonna move to the next column. Okay, criteria gonna be have to be 1. Okay, then I press count 6. Okay, and move to this. Now, so I want this to be this to be 3. Wow. And next is that education female. I'm gonna do again count if now my female is here, blah blah blah. Okay, still here is 1 is equal to 1. Okay, and then I'm gonna copy still to the right. I'm gonna change this into 2 and I'm gonna change this into 3. What wrong is this? Is this I select the wrong? No woman with the higher educations. Wow, that's gonna be impossible. Wow. Okay, no problem. There you go. Then I want to change this into the percentage to let you take a look at that. Okay, the percentage can be okay. Now let's take the whole population. I want to sum them out. So okay, I want to sum them out, and there are many ways to distribute the proportion here. So therefore, the first one is that let me take this B. Now this one is going to be equal to this one divided by this one. Okay, and I'm going to set them. Okay, then percentage. Well, what is number tell? Okay, at least this one you can see that it's difficult for you to interpret. Okay, because you just consider male and female to a group and then you divide by the total population. But this one is going to make you easy to see the whole problem here. Okay, I'm going to copy this again, and here I'm going to have the sum of male. Sorry, some technical problem. The sum of the male. This is going to be the sum. Okay. Now this is going to be equal to this divided by this. Okay, I'm going to take this a little bit. Then this is going to be equal to this divided by this. Okay. Sorry, just a little bit problem. Percentage. Now we'll check if I make it right. Okay, equal 1. Okay, then it's still right. Nothing wrong. We just need to format this a little bit again. No border. And then what I have here is the bottom border. Okay, you can see that the point is that 15% of the male they have the degree of high school and lower. Meanwhile, more than the majority of them having the bachelor degree, and about 30% of them having the master degree or higher. Okay. Secondly, now you're going to see that for female, 60% of more than half of them having the degree of higher education or lower. Okay, and if some of you confused, so I want to explain a little bit. That means if a person is labeled as 1, that means that his or her highest education certificate is high school. If it's 2, that means his or her highest 1 is bachelor, and 3 means highest is master degree higher. So in the female, 60% of them having the education mean that having the higher, only have the maximum into the high school degree. And 40% of them is in the education kind like bachelor degree. Now, as you can see here, you can see and 0 of them having the education of master degree or higher. So here you can see the point that the point is that it is not that gender caused the inequality like in this example. But the point here is that you can see that because the majority of the women they have a very low degrees in education, which lead to their salary lower. Okay, so therefore that in the regression, this is very important, very important. You can never say that a factor y. Okay, I want to write down. You can never say a factor affect to y. Okay, the only things you can say is x, okay, or any factor has the relation to y. Okay, that is because just like this, when you say that, okay, if you say that gender affect y, but normally in the third model, it turned out that gender doesn't affect to y. Okay, that means that gender just somehow having the relation, okay, having some relation to education here, and the education is having the relation to salary. Okay, so that's in this kind of like gender here. Then it's gonna be affect to education, and in the education we're gonna affect to y. And when I say affect here, that means that I already used it wrong. Okay, it's better to say that education has a relation to y. The things I assume here is that education is really affect to y. That means showing some kind that gender does not directly affect to y. Okay, so therefore that very have to be very careful. Okay, of the case you only can use that a factor has the relation to one. Never use it as a factor. Even that, if in the reality, I cannot say that the education has the effect to y, because I can never know with this. The education maybe is going to have an effect to another factor, and that factor has the effect to another factor, and another, and finally effect to salary. We never know. Okay, so only have the effect. Okay, so this is the reason why. So you test me among the three comparison. Okay, therefore that among the three equation or among the three model, definitely that you can see that the third model can illustrate most of the detail. Okay, not just like all the other ones. Okay, so therefore oops, I just messed up my data. Just ignore for this one, don't worry about it. I'll fix that later. So therefore that it is very important for you to master these three ones to prepare for the project. Now for the fourth one, polynomial regression, I'm going to illustrate that on the class. So thank you for listening. The class is now